Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Welcome to a fascinating simulation designed to help you to explore the concept of diffusion. In this journey, you will perform experiments to understand how diffusion works in both gases and liquids, observing how particles move and spread out over the time. Let's break down the science of diffusion through interactive activities and real-life scenarios. Each simulation begins with the game plan. This outlines the overall objective of the simulation. If you are a new user, kindly go through this section thoroughly to maximize your experience. Here we have 4 different parts. The first part is talking about diffusion in air. Let's get into this. Here we have different temperature ranges on the right hand side of your screen, like 50 degrees Celsius, 15 degrees Celsius and 1 degree Celsius. In the center part of the classroom, we have a cylinder which is containing gases, and upon clicking on it, you can release the gas and watch how it behaves in that particular temperature. You can clearly see that the gas molecules are shown over here. The blue ones are the surrounding molecules and the yellow ones are the gases which we have released. By increasing the temperature from 15 to 50, you can see that how easily the movement of the gas particles are quite random and moves quickly as I'm increasing the temperature. What if I'm decreasing the temperature? The movement becomes very slow, which clearly says that decrease in temperature will restrict the movement of the gas particles. You can explore the same experiment by releasing more amount of gases. You can either open the container or close it to observe the behavior of the gas particles. Now let's move on to the second part of the simulation, that is ammonium chloride experiment. Here we have ammonia and HCl. We are going to make ammonium chloride. Before that, observe the cylinder which is attached on the stand. The stand is positioned in the way both the sides of the cylinder are having equal distance. When we start adding the gas particles into the cylinder on the stand, on which side the product will form? That is the question you can ask the students before starting this experiment. Let's see on which side ammonium chloride will form. For that, I'm tapping on ammonia to add ammonia on one side and HCl on another side. After some time, you can clearly view that the circle is formed towards HCl, which clearly mentioned that the mass of the particle is less, then it can move more distance than the higher mass containing molecules. The ring explains about the ammonium chloride formation on the HCl side. Let's move on to the third part of the simulation, that is diffusion of liquid. Here we have two beakers of water and both the beakers are having a tea bag. The difference between these two beakers are the temperature. The first one, that is 10 degrees Celsius, and the second one that is having 80 degrees Celsius. This experiment clearly explains about temperature and diffusion of liquids. Let's dip both the liquids at a time to observe the changes. As I am inserting or dipping the tea bags into the solution of varying temperature, you can observe at high temperatures the liquid particles are diffuses easily than the low temperature solution. You can use the stop clock to stop or reset to start the experiment again. Let's do one more dip and observe the changes. Beaker on the left hand side having less temperature, that is 10 degrees Celsius, so that the diffusion process is much slower than the beaker on the right side that is having 80 degrees Celsius. This experiment clearly concludes that temperature greatly influences the movement of the particles, which affects the diffusion of the liquid particles. Let's move on to the last part of the simulation, that is quiz. Quiz will have an analysis of how many students have understood the concept. Here we have a set of 5 questions and all 5 questions must be answered before clicking on submit button. Upon clicking on submit, you can view the scores you have got from this quiz, and clicking on check answers, you can see which of the answers are right and which are wrong. Also, you can click on explanation button to reveal the solution of the question. Through this interactive simulation, you have explored the process of diffusion in both gases and liquids. By understanding diffusion, your students will gain an insight into a fundamental process that plays a critical role in everything from breathing to mixing chemicals in industrial processes. You are now equipped with a deeper understanding of how particles move and mix and how different factors can influence the rate at different diffusion occurs. Happy learning! Thanks for watching.